Analysis of the available sight distance and its comparison with the required and passing ones is a key activity for adequate speed and traffic signaling management, but also for traffic safety inspection on existing roads. Obligations related to this activity arise from road design norms. However, in the engineering practice so far, analyses of the available sight distance were either inadequately treated or completely omitted. The reason for such a case lies in the fact that there were no appropriate tools for measuring of available sight distance, especially on existing roads. Unfortunately, complexity of three-dimensional road space can't be faithfully represented nor analyzed based on classical geodetic surveys and measurements. As a consequence, traffic accidents under the influence of inadequate sight distance occur every day all over the world. We at the PanPro team have found an innovative solution to that problem using point clouds obtained by scanning the road with the help of mobile laser systems. Our innovative solution is based on the analysis of the movement of the virtual driver in the cloud of points. That is the analysis of his view directed at the virtual obstacle projected at a given distance from him. You could see the movement of the virtual driver and the obstacles within the point cloud in the animation shown in this introductory slide. In the following, we will briefly explain the algorithm for measuring the available sight distance. A simplified explanation of otherwise very complex algorithm for measuring available sight distance is as follows. In the first picture you can see a yellow cylinder object placed 30 meters in front of the driver. In the next image, you can see a series of those cylinders that represent virtual obstacles along driver's path. What we at PanPro team actually did. We have designed a special software solution that automates entire process. First, we place a virtual driver at a given location on his trajectory and virtual obstacle at a distance of 30 meters. If obstacle is visible, we move it for the next 5 meters and so on, until it can no longer be seen. For the subject location of the driver, the length of the available sight distance is equal to the distance to the obstacle, along the axis of the road, where it was last visible. Then we move the driver's position to the next position and repeat the process iteratively along the route. After measurement, we get a diagram of the available sight distance as shown in the following figure. This one, as well as all the other examples in this presentation, were taken from the elaborate of sight distance analysis and definition of measures to eliminate deficiencies that we prepared for the needs of the client Public Enterprise Roads of Serbia on the part of the State Road 1st B22, with a length of 46 kilometers. When we have a diagram of the available sight distance, we can compare it with the required and passing ones. However, since the required and passing sight distance are directly dependent on the speeds, we must analyze them beforehand and correct if necessary. Although the theoretical foundations of speed and sight distance are similar around the world, there are still differences that cause confusions, especially in terms of the use of term names. With the desire to avoid those confusions, in this presentation we will use terms that are widely used and defined by U.S. AASHTO Association. In the following figure, you can see the speed diagram for the existing state. Posted speed limits have been recognized from the 3D camera footage, while the diagram of the inferred design speed was obtained by calculation from elements of horizontal and vertical geometry, which are obtained by recognition of road alignment in cloud of points. In the elaborate in question, the maximum inferred design speed is defined at 80 km per hour, because this is the maximum speed allowed for roads outside populated areas in Republic of Serbia. From the diagram shown, it can be seen that there is a discrepancy between the posted speeds in different directions, but also a discrepancy with the inferred design speed. This leads us to the conclusion that before analyzing sight distances, it is necessary to analyze and correct the existing speed limits. However, it is not enough to analyze their inconsistency in directions and the relation to the inferred design speed. But the process must also include the condition of meeting the required sight distance. We shall explain this process on the next slide. Let's get focus on the speed diagrams of existing state at the top of this figure. Now take a closer look at the relationship between the inferred design and posted speeds by directions. First of all, you can see that the speed in the forward direction is limited to 50 and in the opposite direction to 80 km per hour. Such a difference cannot be justified by anything, and the inferred design speed varies between posted. The difference also occurs in this segment. This essentially means that the currently allowed speed exceeds the values allowed by the elements of the geometry, which is unacceptable. Accordingly, in the next step, we make corrections of posted speed, which you can see at the bottom of the figure. However, the condition of satisfying the required sight distance must also be included in that process. Look now at the sight distance diagrams for the existing state. In it, we can see that in many places the available sight distance diagrams fall below the value of the required ones. We will go through a couple of such places. On this segment, the available sight distance in forward direction drops slightly, even below the value of 57 meter. In the next picture, you can see that the road at that location is in the cut on the right side. Opening the visibility berm at least, with short-term measures, is not possible due to the rock mass on that side. Therefore, we cannot allow more than 50 km per hour in the corrections of posted speed on that part. Although the inferred design speed would allow maybe 60 km per hour. We have a similar situation here. In that part, the required sight distance is hindered by the retaining wall and the slope on the right. Therefore, the speed in the forward direction must be limited to 60 km per hour. Although the inferred design speed does not require it. In both locations, the proposed limit for the opposite direction is higher by 10 km per hour, because the greater available sight distance in the opposite direction allows us to do so. Again, we have a similar situation here. However, in the opposite direction, the required sight distance is obstructed by vegetation, which hides the course of the curve and which could be removed through short-term measures. In the diagram of the proposed posted speeds, you can see that the proposed limit is 70 km per hour for both directions, according to the values stipulated by the inferred design speed. And at the end of this slide, pay attention to the diagram below the ruler, which refers to the fulfillment of the required sight distance for the proposed speed limits. You can notice that the available sight distance now does not fall below the required one, except on the last mentioned segment where we plan to remove the vegetation. On this slide, you will first see a video of a risky passing maneuver that we witnessed while filming, and then we shall show you what the location looks like in diagrams. A couple of notes before we play the video. In front of the truck that will overtake, there is another truck that dictates the speed. In the upper right corner, you can see that the speed is about 60 km per hour. It can be assumed that the overtaking speed is close to 80 km per hour. The video is stopped at the point where the truck starts overtaking. From that place, due to the lush vegetation on the left side, the driver cannot see that a column of vehicles is moving towards him from the opposite direction. You'll notice that overtaking starts right at the start of the dashed line. The driver finishes overtaking at the end of the dashed line, and the tragic consequences were avoided only because of the composure of the driver from the opposite direction. We've stopped the video again so you can see the sign on the left. In the continuation of the video, pay attention to the speed at which the vehicles from the opposite direction are moving in relation to that traffic sign. This is proof that they had to slow down practically to a stop. Now you can see how that location looks like in diagrams. The subject segment where overtaking is allowed in the forward direction is here. In that zone, the posted speed coincides with the inferred design speed and is 80 km per hour. In the sight distance diagram, you can see a reference line that indicates 330 meter of passing sight distance, which is valid for the speed ratio 80-60-80 km per hour in accordance with Serbian norms. However, you can see from the diagram that available sight distance in the forward direction reaches a maximum of 275 meter, and in the opposite direction up to a maximum of 225 meter. This means that there are no safe overtaking conditions at this location at that speed ratio. In the elaborate, we propose to remove this zone since sight distance cannot be improved enough, but let's see what else is problematic. First of all, the length of allowed overtaking. In the forward direction, we have 150 meter, and in the opposite direction 96 meter. None of those values have the minimum required 165 meter for the maneuver itself, not to mention another 2 seconds for decision making. The start of permitted overtaking is incorrectly defined. If the idea was to enable overtaking for a speed ratio of 70-50-70 km per hour, that is, For 260 meter of passing sight distance, overtaking should have been allowed 51 meter earlier, that is, at this point. The driver of the truck that was overtaking at the beginning had sight distance of 260 meter and should have had 330 meter. In the opposite direction, the driver of a passenger vehicle, at a distance of 330 meter, saw only 112 meter in front of him at that moment. We believe that the driver of the passenger vehicle became aware of the situation only somewhere around here, because he needed exactly that length, 90 to 100 meter, to react and stop in front of the truck. Does it make sense to limit the speed to 70 kilometers per hour, and allow overtaking for a speed ratio of 70-50-70 in this zone? Our opinion is that it would be very risky, because the geometry conditions do not limit the drivers to that speed. For the purposes of the elaborate, we have taken data from the official database on traffic accidents in the Republic of Serbia only for head-on collision and overtaking accidents, which we marked in the graphic with the abbreviation TA. Note the location of the traffic accident. In the narrower zone, one occurred in the period 2016 to 2022, precisely at the place where the required sight distance for the backward direction dropped drastically. On the next slide, we will present to you how the permitted overtaking zones are defined in one of the locations covered by the elaborate. Here is a sight distance diagram in existing state for that location, in which overtaking zones are marked for both directions. There are also speed diagrams for the existing state at the top and a proposal for corrections of posted speed at the bottom of the figure. The auxiliary vertical lines delimit the permitted overtaking zone for both directions and extend through all three diagrams. In the speed diagram for the existing state, we can notice that the speed in forward direction is limited to 60 km per hour, and 80 km per hour in opposite direction. The values of the inferred design speed diagram in that part are 80 km per hour. The difference between the posted speeds in opposite directions is unclear and unjustified. Now let's look at the diagrams for the proposed posted speeds at the bottom. In the subject area, the proposed speeds for both directions are mostly around 80 km per hour. In accordance with all the above, we adopt a speed ratio of 80-60-80 km per hour, an overtaking sight distance of 330 meter according to norms in Serbia. On the overview map, you can see that there are no other constraints than geometry and sight distance. We shall also add pictures from the video. This is a picture in the forward direction, and this is in the backward direction. From these pictures, it is clear that the slope of the cut is on the right side of road, observed in the direction of growth of the station. We cannot improve sight distance conditions with short-term measures on that side. However, on the left side, sight distance is obstructed by the vegetation that grows on the slope between the road and river. The removal of vegetation through short-term measures cannot be a problem. In agreement with the client's representatives, we came to a common conclusion that the effective working width of the mechanization, 6 to 7 meter, can be taken as a rational width for removing vegetation. An example of such machine you can see in the next picture. We will now present how the permitted overtaking zone is defined based on the diagram of available sight distance. In the forward direction, we reach the available sight distance of 330 meter at this point. The necessary available sight distance ends here. At that point, the driver can still start the maneuver but must complete it within the next 165 meter, that is, to this point. And that's it. Very simply, we have defined a dashed line zone of permitted overtaking in a length of 245 meter. The opposite direction is a bit more complex. Here you can see the permitted overtaking zone for the backward direction in the length of 295 meter, but how we got there. You can notice that available sight distance does not reach the necessary 330 meter at all, and we started the permitted overtaking zone even much earlier than it is in the current state. In such cases, we have to use the sight lines and their envelope that you can see in the following figure. In that figure you will notice the following: the width of the belt in which we can remove the vegetation. It is the space from the edge of the roadway to the white dashed lines that we defined based on the effective working width of the machinery. Then, there are also overtaking sight lines at every 5 meter. Only those that do not go beyond the desired limit are shown here, because exactly these sight lines determine where the permitted overtaking zone should begin and end. There is also an envelope of sight lines. We shall replace this figure with the following one, so you can see more clearly. Now you see only two sight lines in yellow, which determine the permitted overtaking zone in the backward direction. To repeat, overtaking in this direction may only be allowed if the vegetation in the zone between the edge of the roadway and the sight distance envelope is removed. We start the zone of permitted overtaking at the beginning of the first sight line. The last point at which a driver may start overtaking is here. At that place, starts last line of sight with length the 330 meter measured along the axis of the road, which is within the desired border. The driver must complete overtaking in the next 165 meter to this point, which is halfway through the second line of sight. Please note that 5 traffic accidents of types head-on collision or overtaking have occurred in this zone and its immediate surroundings, in period of 7 years. On this slide you see an example of a layout plan with envelopes of required and overtaking sight distances. We mark the distance from the edge of the road to the red-colored envelope of required sight distance for the backward direction, which is 4.8 meter. You can notice that the wider removal of vegetation is due not only to overtaking, but also to the required sight distance. Also, GIS layers can be created from the sight distance envelope, which can be compared with GIS layers related to data on traffic accidents, which is of particular importance for analyses of traffic safety issues. The detailed analysis we conducted in our elaborate for subject section of State Road 1st B22, 46 kilometers long, led us to the following conclusions. In the period 2016 to 2022, 37 traffic accidents of types head-on collisions or overtaking occurred. The existing state of posted speeds was thoroughly reviewed and corrected due to the observed deficiencies. In the existing state, the required sight distance is not met at over 14% of the length in the forward direction, and at over 18% in the opposite direction. Due to the observed shortcomings, it was proposed to cancel 6 out of 27 zones of allowed overtaking in the forward direction, and 7 out of 28 zones in the opposite direction. All other permitted overtaking zones that can be held have undergone very significant corrections. Also, 7 new ones in the forward direction and 8 in the opposite direction have also been proposed. Thank you for your attention.